Hi kids, this is for my Year 9 GCSE PE class. This is lesson 20. So if you could, I'll put this picture on Show My Homework, so if you could add it to your photo album please. You've already done quite a bit of this lesson because we've talked about long-term adaptations at the end of every body system that we've done. We're going to do it in the same way. Obviously the easier grades is the what in red, how in blue, and then to get your grades up above level 7 you need to be telling us why. We'll take each body system in turn. Some of this is extension learning, so I'll tell you what's the main parts that you need to know for simple GCSE questions. So first of all, let's go for skeletal system. You already know that if your training is weight bearing, then you're going to get increased bone density. Increased bone density is good because you're less likely to suffer from breaks in impact sports, and long term you're less likely to suffer from things like osteoporosis in old age. This next body system that we'll talk about is the muscular system. So initially, muscle hypertrophy. It's important to distinguish really at a higher level between what happens to fast twitch fibres and what happens to slow twitch fibres. For GCSE, muscle hypertrophy is the key, and you don't really have to distinguish, but I'm going to from this point on. So if you train slow twitch fibres, how do you train them? Well, it's got to be aerobic training 3 times a week, at least half an hour in your aerobic training zone, 60 to 80% of your maximum heart rate. If you do that training, then you're going to get slow twitch improvements. You're going to get limited slow twitch hypertrophy. The most important thing about those slow twitch fibres is that you increase your amount of myoglobin. Remember, myoglobin transports oxygen from hemoglobin in the red cells to the actual muscle cell, to the mitochondria. Mitochondria, remember, are the aerobic power cells of the cell. It creates aerobic energy. So, surprise, surprise, you get increased myoglobin and increased mitochondria. What does all that mean? Well, obviously it means improved muscular endurance in those slow twitch fibres. If your training was high intensity, then you're going to get fast twitch hypertrophy. Fast twitch fibres actually hypertrophy more than slow twitch fibres. What's great about fast twitch hypertrophy? Well, the greater the size and the diameter, the greater the power, the strength and the speed that those fast twitch fibres can exert. So brilliant for sports like 100 metre sprinting. Let's move on to the respiratory system. So respiratory muscles are responsible for inhalation and exhalation. Guess what? The diaphragm and the external intercostal muscles become more efficient. So they're better at manipulating the size of the thoracic cavity. So you get more efficient breathing. You can breathe quicker and you can breathe deeper. You also, in your lungs, use a higher percentage of the alveoli that you have, and you get capillarization around those alveoli. If you train in your aerobic training zone 3 times a week, what does all of that mean? It means that you're more effective at getting oxygen into your body, and then that oxygen can be transported by the cardiovascular system to our muscles that need it. Your tidal volume, the volume of air you breathe per breath, and your minute ventilation, the volume of air you breathe in or out per minute, and your vital capacity, the maximum you can breathe out after the maximum you can breathe in, will all increase. Your total lung volume will increase. You'll be more efficient at gaseous exchange, getting oxygen in, getting carbon dioxide out. Your cardiovascular system then, that improves due to aerobic training as well. So the oxygen that you got into your body via respiratory improvements can be delivered more effectively due to cardiovascular improvements. So cardiac hypertrophy, the actual muscle of the heart, gets bigger and stronger. What does that mean? it means that your resting stroke volume and your maximum stroke volume, the amount of blood you pump out per beat, will both increase. That means your maximum cardiac output, the maximum amount of blood you can transport per minute, will increase. It means your resting heart rate can decrease, which is great for our overall health. And also, you're going to create more red blood cells. Why are red blood cells great? Because it's the hemoglobin in the red blood cells that carry the oxygen to the muscles. And the smooth muscle in your arteries becomes more elastic, which means that you're better at vascular shunting. If you're better at vasodilating to the working muscles and vasoconstricting to the non-essential organs, such as the intestines and the bladder, it means more blood can be distributed to the muscles during exercise. What does all that mean? It means your aerobic capacity increases. What does that mean? That means that a marathon runner, for example, can run at a quicker speed and yet stay aerobic. He won't be building up lactic acid now at 8 miles an hour, whereas before it might have been 7.8 miles an hour and he started to build up lactic acid. So it means he can finish the marathon quicker. It also means that you can recover quicker after anaerobic bursts. Last system is energy systems. So again, the energy system you improve will depend on the type of training that you're doing. If you're doing aerobic training, then obviously it's going to be your aerobic energy system that improves. What does that mean? It means that you can tolerate higher levels of lactic acid, which again means that you can work at higher intensities before fatigue sets in. If you're going to train anaerobically, then it's fast twitch fibers and fast twitch energy systems that really improve. You get more stored ATP and more stored PC, which means you can work at a maximum intensity for slightly longer. So maybe you can work at a maximum intensity for 12 seconds rather than 10 seconds. This slide will go on show my homework. Please add it to your photo album. Thank you very much.